explain about a project titled Improvement of Image Transmission Using Chaotic System and Elliptic Curve Cryptography. So now coming to the introduction part, the integration of chaotic dynamics adds an extra layer of unpredictability, making the encryption scheme even more resilient to potential cryptanalysis techniques. Overall, the improvement of image transmission using chaotic systems and elliptic curve cryptography presents a promising avenue for enhancing the security and efficiency of modern communication networks, thereby fostering trust and reliability in image exchange. By sincerity integrating these two cutting-edge technologies, the proposed approach endeavors to achieve a higher level of confidentiality and integrity for image transmission while maintaining computational efficiency. So now coming to the objective part for this project is to establish an image transmission system that guarantees confidentiality, integrity and authenticity of transmitted images, ensuring that only authorized parties can access and interpret the data. The proposed improvement aims to increase the overall trust and reliability in image exchange, enabling seamless and secure communication across various platforms. By achieving these objectives, the integration of chaotic systems and elliptic curve cryptography can pave the way for safer and more efficient image transmission in a wide range of applications, including medical imaging, surveillance, and multimedia communication. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirement, first operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE, that is 3.7 version is required. So now coming to the methodology part, first upload image. Upload image refers to the process of transferring an image file from a local device such as computer or a mobile phone to a remote server or platform for storage, processing or sharing purposes. Second, generate Diffie-Hellman shared key. The Diffie-Hellman key exchange is a cryptographic protocol used to establish a shared secret key between two parties over an insecure communication channel. The process involves each party generating a private key and a public key. The public keys are then exchanged, and from this exchange, both parties can independently compute a shared secret key. This shared key can be used for secure communication such as encryption and decryption between the two parties without transmitting the private keys over the network. Third, chaotic XOR encryption using pixel grouping. It is a technique that utilizes the XOR, exclusive OR operation along with chaotic dynamics to encrypt data such as images. In the context of images, this encryption technique involves dividing the image into pixel groups and then applying a chaotic algorithm to generate a chaotic sequence. Each pixel group is then XORed with the corresponding chaotic sequence, effectively scrambling the image data. Fourth, chaotic XOR decryption. It is the reverse process of the encryption method explained above. After an image has been encrypted using chaotic XOR encryption, decryption involves applying the same chaotic algorithm to generate the same chaotic sequence and used during encryption. This chaotic sequence is then XORed with the encrypted pixel groups to retrieve the original image data, effectively reversing the encryption process and recovering the original image. Fifth, comparison graph. A comparison graph is a graphical representation used to visually compare and analyze data from different sources or scenarios. In the context of the topics discussed, a comparison graph could be used to illustrate and compare the performance of different image encryption methods such as the chaotic XOR encryption against other encryption techniques. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as images. In this we are containing some images over here. And here this is the Python file which is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on upload image button to upload image to the application. So here I am selecting this image and now click on open button so to get the output. So here on this screen you can see that image is loaded, and now closing this image Click on Generate Diff Helmet Share Key button to generate key for getting the output. So here on this screen you can see that secret shared key is 75, and now click on chaotic XOR encryption using pixel grouping. So here on this screen you can see that first image is the original image and the second is the encrypted image. And so now closing this image, click on chaotic XOR decryption button to decrypt image using with and without inverse modulo for getting the output. So here on this screen, first image is the original image and the second one is the encrypted image. And here third one is the decrypted image using existing technique which is not clear. And here fourth one is the decrypted image using proposed inverse modulo technique which is clear than existing technique. And so now closing this image, in upper screen, in this screen over here you can see that existing PSNR we got 70% PSNR and SSIM as 0.92, and with purpose we got PSNR and SSIM as 100%. So now click on comparison graph button to get the graph. So here on this screen you can see that x-axis represents technique's name and here y-axis represents PSNR values, and in both technique proposed got higher PSNR. Similarly you can upload and test other images, and so here now closing this graph, you can try with other images also. So now coming back to the conclusion part. In conclusion, the improvement of image transmission using chaotic systems and elliptic curve cryptography represents a promising avenue for further research and development. As technology continues to advance in incorporating these innovative techniques into mainstream communication protocols may become essential to counter increasingly sophisticated cyber threats. This enhanced security comes without sacrificing computational efficiency, enabling real-time image transmission even in resource-constrained environments.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.